F is continuous. Did I have that written there? Did I have that this is a max? Did I have that this is a min? Okay. And then did I have this graph where I have A here, I have B here, and I had something like this, where this is B, F of B, and this is A, comma, F of A, and this was right here a C, and what was right here? There was a what? A hole, correct? So F is not continuous. So this is an example that in this picture there is not a what? No max. I think I even wrote it down there. I made it look like one word. Right? If I remember correctly. So this is an example of a graph that does not have a max because the function's not continuous. I could draw a graph very similar to this in which it doesn't have a min. Would you agree with that? How do I do that? I just flip it. I could have something that looks like this. So this is an open interval, but F is continuous on from A to B, the open interval, correct? Is there a max on this one? What do you think? Let's say this is 3. 3 doesn't exist, right? B, comma 3 is open. But I could get really close to B and get really close to 3, right? Like 2.9. Could I get closer than 2.9? Can I keep getting a number bigger than what I had before, but not be 3? So is there a max? No, because whatever you say the max is, you can pick a number that's bigger. That's how the decimal system works, right? Yes, ma'am.
You never put like 2.9 repeating, the 1 over 9.
Because 2.9 repeating is exactly 3. I learned that when I was in 8th grade. And then I learned it again when I was in calculus. Because it's an infinite limit. Have you ever seen that? Okay. So this is the way I learned it when I was a child. Okay. You say x is equal to 2.9 repeating, or 9 repeating, right? And then you multiply by 10, and you get 29.99 repeating, correct? You subtract both sides, you get 9x is equal to 27. And that means when you divide both sides by 9, you get 3. But x is equal to 2.9 repeating. Hence, they have to be the same. So I thought that was a pretty cool proof. And then I had a 7th grader that said, really? Here's my proof. And he did it with showing that 2/3 is 0.6 repeating. He said, Mr. Kruger, 1/3 is 0.3 repeating. Oh, I know he did. He showed that 0.9 repeating is 1. That's what he did. And he said 2/3 is 0.6 repeating, because I can demonstrate that by division. And when you add this, you get 3/3, and over here you get 0.9 repeating. Well, 3/3 is the same as 1 whole. Hence, they got to be the same. I showed that to a college professor when I was working on a master's degree. He thought that was the greatest proof in the world. I'd never seen it. Alrighty, so, not guaranteed a min or a max, right? No min, no max. Here we have one for sure. So, we have something called the extreme value theorem. Extremes means you can have min and maxes. And it has two requirements. One is that it's continuous. And second, it's on a closed interval. So they'll give you an example. They'll say f of x is equal to x cubed plus x on the interval 1 to 3. And they'll either write it this way or they'll write it this way. And they want you to find the absolute max and absolute min. Now, there can be more than one. If I have a horizontal line, if I have this, the maxes and mins are equal to each other, correct? And there's an infinite number. The theorem doesn't say that there's only one. It says you can find them. And you don't have to look at every single spot. You only have to look at the endpoints like this. And where else do you think you have to look? I'm going to give you a hint. What if I had something that looks like this? Here's my graph. Here's A. Here's B. That's the minimum, correct? Is this the maximum? Yeah.
So you just need to look at the endpoints in the extreme.
Say it again.
The endpoints in the extreme.
To find them, you have to look where?
The endpoints and the extreme.
You have to look at the endpoints and the extrema. Okay? I'll show you how I look in the endpoints. I plug 1 into F. Okay, now this is a different example. I didn't look at this graph, but do you see where I get 2? And then I plug 3 into that, and I think I get 27 plus 3, which is 30. That's looking at the endpoints, correct? How do I find the extrema? How do I look at the extrema? How do I find this spot right here? What do I know about this spot? It's concave down, okay? I'll agree with that. I want to find this spot right here. How would I find it? It's a special kind of point, yeah. The slope of the tangent line is 0. Always. Always, always, always. The slope of the tangent line is 0. So, what does that mean? Ethan?
Goes from increasing to decreasing.
It goes from increasing to decreasing. I agree. But let's go back. The slope of the tangent line is 0. How does that help me figure out what x I want? I have 1. That's the left endpoint. I have 3. That's the right endpoint. How do I determine if there's a point that turns around here? Yeah.
Couldn't you just find the derivative?
Okay. Find the derivative. I get 3x squared plus what? 1. Okay? What do you want me to do now?
Set it equal to 0.
Set it equal to 0, because I know the slope is 0, correct? 0 equals 3x squared plus 1. I get negative 1/3 equals x squared. Bren, would you agree with that?
Sure.
I subtracted 1 divided by 3. What does that tell you?
There it could be positive or negative.
When you square a number, I get a negative 1/3. That's what that sentence says. It says you're taking a value, you're squaring it, and I get a negative 1/3.
So that's not,
What?
so that's not right.
What do you mean it's not right? I did exactly what you said. I took 3x, took the derivative. That is what you want to do. You make it equal to 0. That's what you want to do. I'm this far. Should you want me to keep going?
I don't know.
Okay. Anybody know?
Is it imaginary?
Oh, we do, it is imaginary, and we don't deal with imaginary in here. It's already hard enough. Let's not go to pretend and make it more abstract. So what do you think the answer is? It doesn't exist, right? For sure it doesn't exist between 1 and 3. There's no I in 1 or 3. That was supposed to be a joke. You know, there's no I in teen. Okay. Well, anyway. This has no solution, correct? So there's no turning around point between 1 and 3. It goes from 1 comma 2 to 3 comma 30. It's positive the entire time, isn't it? For whatever value I put in for x, it's positive. This function is always growing, isn't it? If it's always growing, can it have a horizontal tangent line? Can it turn around? No, not if it's always growing. So this is the absolute max in this interval. This is the absolute min in this interval. Yes?
You changed the interval, that wouldn't change anything you did with the derivative.
Correct. Because this is always positive, right? Right? For whatever x you put in there, it's always going to be positive. Okay? All right. So let's look at the next page.
Mr. Gerber,
Yes.
if you would have gotten a value for that, what would that have been?
Okay, we're going to get to some and I'll show you. Okay? Let's say I have this. Let's look at that one. Which means this. Correct? Right? Isn't that what that means? So, I look at the endpoints. I put in -1. What do I get? Somebody gave me the finger. That's correct. See, that's a joke. I didn't know that joke when I was 8. I learned that joke when I was 9. I'll tell that story sometime. I do not have time. What if I put 1 in there? What do I get? 1. Okay, so I check the endpoints. What's the next thing I do? What did Bryn have me do? Take the derivative. So I'm going to use this. And the derivative is what? Do you see? You still need to know the power rule, correct? You don't get to forget about it because I moved to a new chapter. Noah, what is that derivative? Of this.
Oh, 2/3 of x to the 1/3.
Okay, that means if I write this out, remember my purpose is to figure out values, correct? Figure out numbers. How do I write this? What does this look like without exponents? Alex.
2 over 3 times the cube root of x
Where is the cube root of x?
by the 3 underneath.
It's in the denominator, isn't it? Now, this numerator cannot be 0, can it? In fact, if I put 0 into here, this derivative is undefined. Would you agree with that? Now, if I put 0 into here, this derivative is undefined, correct? Is 0, can I put 0 into the function? I can put 0 into the function. In fact, if I put 0 into the function, here's my graph. There's 0, 0. It's a turning around point, correct? But it's a what kind of turning around point? It's a sharp one, right? In which it means the derivative is not defined at 0, 0, but the denominator can be 0, can't it? And 0 is allowed in the function. It gets invited to the birthday party, doesn't it? So it indicates when you have 0 in the denominator, it indicates you have a sharp point. So if I were to graph that, here's -1, 1 right here. Here's +1, 1 right here. It looks like this, blown up. It's a sharp point. So these two values are what? In this interval. What are these 2 points? They're the what? Are they max or mins? They're absolute max. I don't get higher than 1, do I? On this graph? And when I put 0 into F, I get 0. So 0, 0 is the absolute min. So the moral of this story is you have to find what values give you 0 both in the numerator and in the denominator. In the denominator, they will be sharp points. In the numerator, they'll be nice curved points. There'll be a smooth curve. Let's look at this. F of x equals x squared from this interval, -1 to 1. So, like Josh said, is you check the endpoint. So am I going to put a -1 in there? I'm going to get 1, correct? If I put a +1, I get 1. Remember, I'm not looking at the whole thing, just between that interval. Now I take the derivative, f prime of x is equal to 2x. I set it equal to 0 because the the denominator is 1, correct? I get 0. I plug it into f, and I get 0. In other words, here's -1, here's a +1. This graph looks like this. Doesn't it? So this is the min, absolutely. And these two are the max, absolutely. All right, so let's look at these questions. Do min and maxes occur only at endpoints? The answer is where? What's the answer to this? No. Okay. They can occur where? At where? Extrema. How do you find the extrema? You do what first? What did we do on 1, 2 examples? What was the thing? Did this have an extrema? Did this have an extrema? How did I find those extrema? I did what? I took the derivative. So what you do, you find f prime. Let the numerator equal 0. Let denominator equal 0. These are sharp points. These are smooth points. These values that give you 0 are called critical numbers. Critical numbers are simply those numbers that make either the derivative, numerator derivative, or the denominator derivative 0. I've explained the difference between relative max or local max and absolute min or global min, right? I talked about that already. Definition: if there is an open interval containing C on which f of C is the maximum, then f of C is called a relative maximum. If there is an open interval on C where f of C is the minimum, then it's called a relative minimum. And so this is what I'm taking a look at. This is a relative max. This is a relative min. Absolute min, would you agree? Absolute min, would you agree? Sharp point? Smooth point, would you agree with that? Here the derivative doesn't exist, but this value exists in the function, doesn't it? Here the derivative does exist, and its value is in the function. Next page. Okay, slopes at relative max and mins are 0. Slopes at relative max and mins do not exist. So here are my examples. F of x equals x squared. F prime of x equals 2x. X equals 0. This right here is my critical number. It's a nice, smooth point. This one right here, f of x equals x to the 2/3. F prime of x equal 2 over 3x to the 1/3. This thing was 0. This derivative does not exist because you cannot divide by 0, but 0 can be used in this function. You can take 0 to the 2/3 power. So what does this mean? This number, this critical number, creates a sharp point. Because I can't put 0 into here, but I can put 0 into here. And simply because my denominator is 0, and I can use it here, means it's a sharp point. Relative max and mins only occur at critical numbers. How do I get critical numbers? I take the derivative. But critical numbers do not always yield relative extrema. Here's my example. F of x equals x cubed. The derivative, and that looks like this, by the way. The derivative is 3x squared. For whatever number you put in here, so I make this equal to 0, and I get x equals to 0, correct? But when I put 0 in here, when I look at this, this is what the graph is. This is not a relative min or max, is it? Because this function says for every other number, for every other x besides 0, this function is positive. Excuse me, the derivative is positive, meaning the function's always increasing, correct? So something special is happening here. Does anybody have an idea what's happening here? Yeah.
The concavity changes.
Yeah, the concavity changes. We went from concave down to concave up. So when you do this, when you find where x equals 0, you have to make sure that f goes from increasing to decreasing or from decreasing to increasing, correct? So here are the guidelines for find the extrema on a closed interval. You find the critical numbers between a and b. How do you do that? You take the derivative. But make sure you look both in the numerator and in the denominator. Figure out your y's at those critical numbers. Look at the endpoints. The least of those values is the minimum. The greatest of those values is the maximum. Next page. I can't even see what this says. I think it says 4 and 3, correct? So I do it a little bit backwards. I'm going to put in the endpoint here. I'm going to put the left endpoint in. I put a -1. So I have 3 times -1 to the 4th minus 4 times -1 to the 3rd. I believe that's correct. What does that give me? Sophia, what does that give me? 7. So then I plug in 2, and I get 3 times 2 to the 4th minus 4 times 2 to the 3rd. Ooh, what is that? What's 2 to the 4th? 16. What's 3 times 16? 48. What's 2 to the 3rd? 8. What's 4 times 8? 32. Do I get 16? Now what do I do? Is this my min? Is this my max? Morgan, what should I do?
You should find the derivative.
So I'm going to take the derivative. I'll find the derivative. I can do that. 4 times 3 is 12x cubed minus 12x squared. Okay? What do I do once I do that? Savannah? I must make it equal to what? 0, because I have horizontal tangent lines, correct? So I've got 0. Can I factor anything out here to make my life easier? 12x squared. And I get x minus what? 1? Okay. And what do I get here? What are my critical numbers? X equals 1. Anything else? 0. Would everybody agree? So what am I going to do with 1 and 0 now? I'm going to put them in the y values, right? I'm going to put them into f. So I put 0 in there, and what do I get when I plug 0 into f? 0. What do I get when I plug 1 into f? -1. So my numbers are 7, 16, 0, and a -1. I have 4 possible answers. Which one's the absolute max? 16. Absolute max. Which one's the absolute min? -1. Absolute min. And so what I do here is I look at the left endpoint. The left endpoint was -1, comma 7. This was, the right endpoint was 2, comma 16. Those are my points, right? And then I had 0, 0, and then I had 1, -1, right? So I could graph those if I chose to. Here I just ask you to find the extrema. That's all you have to do. So the extrema, Noah, are those values in which there are turning around points. Okay, so what do I need to do to be able to do that? I need to take the derivative. So what's the derivative of this? 2/3 times 3. You have 3 candy bars. What? 2. X to what power? -1/3. Which means now I'm going to make that equal to what, Becca? 0. Oh, you're going to do that.
Subtract the 2.
See, that's where people make their mistake. Okay? This is what you have to do. This is 2 over 1 minus 2 over x to the 1/3. Okay? Because the number down here could be a critical number. The number down here could be a critical number. So I have 2 fractions. What's the common denominator? X to the 1/3. So I got to multiply this by x to the 1/3. And so what this becomes is 2x to the 1/3 minus 2 over x to the 1/3. And I've got to take this numerator, 2x to the 1/3 minus 2, and make it equal to 0. And what do I get here? I get 2x to the 1/3 equals 2. X to the 1/3 equals 1. That means x equals what? Did I make a mistake, Lillian? Okay. What is it equal to? 1. And then I got to take this denominator and make that equal to 0. And I get 0. Why do I make it a 0? Because I can put 0 into here. Right? It doesn't cause division by 0, so I'm allowed to put 0 into there. So this is a critical number, and this is a critical number. So if I look at this graph, and I put in 2x minus 3x to the 2/3, is that what it says? Okay, and so then I go to my window, and I'm making my window, my interval from -1 to 3, and I graph it. It looks like this. Can't see it. Looks like this. You see this spot here? That's a sharp point. If I change my window a little bit, it'll be easier to see. I'm going to make this from -5 to 5. There it is. Do you see that this is a relative max? And that's at 0. And at 1, Right here, I have a relative min. And what I can do to check it is I go second calc. I can go to minimum 3. You guys knew you had this? Well, you do now. Go over here to the little bit to the left, enter, go a little bit here to the right, enter, enter, think. And that's 1 because that's the best this calculator can do. It's not very bright. It's because it's a TI-83. Okay, and I get a -1 in there. Okay. So that's a relative min, that's a relative max. Does that make sense? But if I didn't look here in the denominator, I would have missed this one at 0, 0. Okay. Find the extrema on this one. Great. Trig. Allison, what's the first thing we're going to do? Take the derivative. F prime of x. What is it equal to? So take the derivative of that first. 2 sine of x. 2 cosine x minus. Give you a hint, I'm going to put parentheses around that. What?
Negative sine 2x
Times 2. Perfect. Which gives me 2 cosine x plus 2 sine of 2x. Correct? Which is the same as this. 2 cosine x plus 2 times 2 sine x cosine x. Remember, these are equivalent. Yes? Yes. There's two that you need to know. That cosine squared x plus sine squared x equals 1, and that the sine of 2x is 2 sine x cosine x. Just those two. So now that gives me, I'm going to make that equal to 0. I got 2 cosine x plus 4 sine x cosine x. All right, I am not here tomorrow. Tomorrow will be a work day. You will have Mr. Karsh here. You can work on your yellow sheet, and you can work on in the book. You cannot use your computers or your phones tomorrow. Have a